This is Praveen Kumar Sinha, Deputy Director General, Geological Survey of India. I retired last year. Today's topic is georeferencing, digitization, and attribution in QGIS. I will be presenting how to achieve these tasks in QGIS. So let us launch QGIS. When you install QGIS, it will ask for shortcuts at desktop, and these shortcuts will have this type of a look. You have to launch QGIS desktop 3.12.3. When you double click it, it will be launched, and after it get launched, it has this look. This is a typical look of GIS when it is launched. It has one broad blank area which is called display device. Here the maps are shown. This is table of content. What are the layers we are opening? That is listed here. We have tools or menu and toolbars. These are toolbars and this is menu. Let us start with georeferencing, which is my first topic. Why georeferencing is required? As you know, we are using one GIS. What is GIS? GIS is map handling device. For map data, this is the device which can handle different maps. My question was why georeferencing is required. As you know, that old days maps were prepared on papers and it is stored like that in our libraries. So it is not available at a digital platform in digital format. We will be taking this map or paper map and scanning it with a scanner. I am opening a scanned map. Go to what type of map will be available after scanning. It will be a raster layer. So I will be opening a raster layer. I will be going to layer and add layer. What type of layer? Add raster layer. This assume that this layer is scanned and I have kept it the scan file into my folder. I will be guiding this dialog box. Where is my raster map? By clicking this tab, it will prompt me where indicate the map. So this map is available in trainers folder. I will be going there. So you see this is the map. The map in TIFF file format is now getting opened. Add it to the table of content. Table of content is now populated with the image Hussain Sagar. This is a raster image which is supposed to be a scan map. Now open. Let us close this dialog box because our map is already displayed here in the display device. Now we have to georeference this map. Because this is a scanned, it has lost its georeference. We don't know the corner coordinates. So what will be our approach to achieve this georeference? So there may be two methods of georeferencing. Sometimes your scan map may have corner points or the cross points of longitude latitude where values are written. Okay, at what longitude latitude this cross point is there. But here in this map we don't have cross points. So how we will be georeferencing? That is our problem. If cross points are there, means cross points, those longitude latitudes are our control points on paper map which can be allotted for georeferencing. but here we don't have those corner points. So we will be registering this image or scan map by GCP points, ground control points. What are the ground control points? Ground control points are those points marked on the map where we have recorded the longitude latitude value by, say, now this device is there, GPS. Here on this scan map we have 5 locations, 1, 2, 3, 4 and 5. These 5 locations are GCPs, means they have their coordinates known to us. By registering these points, we will be georeferencing this scan map. What are the coordinate values here at these 5 points? That is noted down into another file, which is with a PowerPoint. You see there are 5 IDs corresponding to what is there on the map, and their x coordinate value means longitude value, and y coordinate values is shown in tabular format. So these are the recorded values from say GPS while field work. So we will be entering these values to corresponding points at the time of georeferencing and get the map georeferenced. Now we have come again back to our QGIS, and now we will be opening the georeferencer of the QGIS. Going to raster and see here that tool is the georeferencer. So we will be clicking here. We will be opening the image here. This is Hussain Sagar TIFF. Open here. Now the same map of what is there in the background. Let us remove it from here because this is memory expensive. Okay, and we will be zooming to the first point. Here what is the value? Let us take it from the file. So this is first point. X value is this 78.462, like that. For be more accurate, we should provide the whole length of the reading of GPS. Now go to edit, add point. This is, and we will be clicking at the center of this symbol for GCP point on the map. Now X value and Y value we have to assign. X value I have already shown you. X value is this, Y value is this, 78.462. 78.462 and Y value is 17.437. 17.437. Okay, now when I OK it, you see this table, first row of this table is generated, and this has recorded the value. So this way we will be going to register all the points, all 5 points which qualifies as GCP. One method is this method. XY values are known to us and we are registering those points, and then or transforming the image. The latter steps we will be seeing in other exercise. Let us close this. So here one more step will be there. we will be covering it in another exercise with georeferencing. So let us close this window here, and we will see the other way of georeferencing. Let us close that window, and we will be using another method of georeferencing. Nowadays, we have plenty of resources available on web as a map source. They have a very accurate locations. So let us open that type of map. So go to web, and we are opening the web map of OpenStreet and OpenStreetMap. So let us open this OpenStreetMap. OpenStreet I will be opening. So this is the OpenStreetMap. Now table of content, you see OpenStreetMap. Now zoom to the location where we will be. Hyderabad. So still down. Pan tool. I am using pan tool. Panning this here. Warangal, this is Hyderabad. So we will be using zoom in tool, covering a part of Hyderabad and Hussain Sagar area. So this is that area. When this is opened in background, let us see what is its projection. So here the system reports that this map is projected into 3857. So we will be providing our projection to this data, which is being fetched from web server. So let us take 32644. So this is UTM projection and 84 WGS 84 datum, zone 44, UTM zone 44 related data. Hyderabad falls in UTM. You see Hyderabad falls in UTM 44. This band shows the UTM zone. So take this zone to current view, reproject the map displayed on the display device to this projection, UTM projection, and OK this. So this is listed here. So that will be the current projection of the display device. This area is now master because this is a reference map. Means coordinates are known here, distances are known here, projected map, so distances are known here. Now I will be opening the other map, which is Scanned Map, and in the Georeferencer. So invoke Georeferencer here, and here I will be opening that Scanned Map. That is getting opened from my resource that is not web map. So this is my resource. Open this. Those 5 points are here. Drawing tie lines between these points, and we will be registering it by the coordinates of a master. So how this has to be done? So let us first enlarge this point. This is a slave image. Slave image has to be opened in Georeferencer because ultimately that slave has to be georeferenced. Now I have zoomed to the and now open the add point, and first point is this point, central point of this here. So this dialog box is invoked, X point I have already, by clicking here, I inform this system the coordinate location of the paper map is taken from that point. So system has read that point. Now I have to register it from the map canvas, which is master which is available in master layer. So I will be zooming it that location for first point. So this is the first point, and so by that time I lost the connector, so I will be invoking it again and again, clicking it here, and this is generated. So that cross point is being somewhere here. Okay, so I will be clicking. Now you see both the values, x values and y values are registered. This is not longitude or latitude. Okay, the first point is now registered. Similarly, we will be going zoom out. Second point needs to be zoomed. This is Panjagutta Chaurasta. If you are aware of Panjagutta, so this is Panjagutta Chaurasta. Similarly, we will be going here. This add point tool is this tool, and we will be clicking the first point here. When this is invoked, let us click here. So now we will be zoom out to see the broad area, and then focus at the zoom in. The Panjagutta Chaurasta is this Chaurasta. So the second point has to be here of that tie line. So again I will have to invoke this window and take the from map point. So now this is recorded here. So you see second row is also generated. Zoom out. Third point is here. This is, sorry, zoom in. Starting point of the tie line. Zoom in. The corresponding point. Now invoke this first point. Take this master point. Okay, so third point is now registered. Similarly, fourth point has also to be registered. Take the full view of the map, then enlarge the particular portion. Say this is Paradise Chaurasta. View, zoom out. Paradise Chaurasta is this Chaurasta. Again, zoom in. That Paradise, zoom in. Now here again you have to invoke it from map to this point. So this is a fourth point. For a registration purpose, at least you should have 4 registration points. These points should not have a collinearity. It should not fall in one line. It has to be distributed all through map. So best result will be in that situation. So okay, so fourth point is now registered. already 4 points are registered. If you like, you register this way, the 5th point also. Now here afterwards you have for both the types of referencing. The earlier what I was showing in georeferencing by recording the key longitude latitude value directly, key entries. Now here by tie lines between master and slave. So now you have to set the transformation type. So what type of a transformation we are going to do is transformation of a projective type. Resampling method is a cubic spline method. We have these options. So we have to take a cubic spline, nearest neighborhood, linear, cubic, and a cubic spline, and a Lancozos. 4 methods are there. We will be taking cubic spline method, and target SRS should be this 3264. Our map coordinates, returned map coordinates will be in UTM projection. Output raster names will be Hussain Sagar in trainer folder, and it is UTM 44, and no compression is required. Save GCP points, yes, it needs to be saved, and you should check the load in QGIS when done. So that map will be opened as main map, main display device when process is completed. So we have set the parameters of a projection or georeferencing, and now we have to run the georeferencer. Start georeferencing. Click this triangle tool. So it is already georeferencing done, work is done. Now you can see this Hussain Sagar UTM 44 is now opened. Let us remove the here. So you see, just below that view of this Hussain Sagar is there. So this corresponds to the 4th point, corresponds to 4th point of this here. Now you can remove this layer, which is being read from web server. So we have removed, our map is already available at a georeference location, and now you can see the whole map. So this is a georeference map, which is georeference as well as projected.